We're trying to find the average value of this function, and we're given some boundaries for it too. So first of all, let's try to draw this on our little coordinate system. We've got x equals 0 is going to be one of the lines that is important, so it's going to be this line. Then we have x equals 1, which is going to be kind of like this line right here. And then we'll have y equals 5x, which you could draw maybe like this. And then we would have y equals 10x, which you might be able to draw like this. We're going to have this little region right here. So a little triangle. And if we try to figure out what the coordinates are, here would obviously be like 0, right, for this x. And the x goes to 1 over here, so 0 to 1. And then if we were trying to figure out what these y's are, remember that this is the line 5x, and then this is the line 10x. So we kind of already have, like, our integration limits have been given to us, essentially. It's going to be those. Now, we're trying to find average value. So that just means f average equals 1 over area. And we got a double integral of a rectangular shape. fxy is our function, and then we have dx dy. So got the function. It's just going to be e to the x squared. We've already figured out our integration limits, so we'll put dx on, I guess we'll do the dx on the outside, 0 to 1, and then we'll have 5x to 10x as far as the y's go, dy and then dx, because I want to integrate the y's first, just because I noticed that there's no y in here. So if I can just integrate that by adding a y, it's going to be a really easy integration. We'll deal with the dx and stuff later. We also have to find this area, because we're going to divide our answer by the area. So we're going to try to figure out the area by just doing a quick little integral. We're going to cut that part, and we're just going to integrate 0 to 1, 5x to 10x, dy dx. We're just going to do that integral. We're going to integrate to find the area first. If we do that, then we're just going to say y, going from 5x to 10x. That's going to become 10x minus 5x, which equals 5x. And then we're going to integrate that over x. And so now we're going to do that from 0 to 1. And we're basically just going to get 5 over 2 is the area. So we're going to take the reciprocal. We're going to multiply it by 2 over 5 over here. So that way we divide it by that area. And now we've got this thing. So we can do this integral in the middle here. It's going to be pretty easy. Again, we just stick the y there, e to the x squared. We're going to go from 5x to 10x. And that's going to go in the y's. So we'll get 10x and then e to the x squared minus 5x e to the x squared. Of course, you can kind of pull out those e to the x squareds, and you'll get 10x minus 5x, which is just 5x. All right. From here, we still have to integrate over x now. And multiply it by this thing. And at first you might be tempted to use the di method or by parts, because you see two different portions here. But because we're doing exponents, logarithms, and exponents, and things like that, trig, it's really good to do u-subs for that. So we're just going to take a u-sub of x squared, and then if we do a du, it's going to equal 2x dx. And it's really nice that we have an x there, because we can divide that over here right now. And we'll say that there's a dx equal to a du over dx, du over 2x. So let's go ahead and try sticking that into here. We're going to get 2 over 5, 0 to 1, and that's actually x equals 0 and x equals 1. We'll have to try to figure out what that actually equals in terms of u's. And then we're just going to plug in e to the u, and then we have 5x, and then the dx becomes du over 2x. So the x's are going to cancel here. We're going to get the 5 over 2. We're going to pull that out, and these things are just going to cancel. And then we're going to just basically get the integral of e to the u. But we still have to plug in our u limits over here. So we're going to be x equals 0. If x equals 0, u equals 0. And if x equals 1, u equals 1. So it's the same integration limits. So we're just basically going e to the u, and then taking the integral, which is just e to the u, and then we're just going to go 0 to 1, which means that it's basically e minus 1 as the answer.